Hi, this is Prasanna from Wave Academia. In this video, we are going to discuss about how to develop solar photovoltaic system using Matlab. The agenda of this video is we are going to discuss how to connect solar photovoltaic cells in series and parallel combination, as well as how to obtain the characteristic curve of solar photovoltaic module, that is voltage with respect to current curve and voltage with respect to power curve. I am straight away moving on to the Matlab. So in this model, I'm going to pick a solar photovoltaic array from the library. Just go to library, go to Simscape. From there, go to electrical, go to specialized power systems, go to sources. So inside the sources, you can pick solar photovoltaic array. Array means the number of cells which will be connected in both series as well as parallel connection. Actually, I'm not going to use array. I'll use only cell. So if you double click the array, you can see that the number of parallel strings will be 40. Series connected modules per string is 10. That's why it is called as array. But I'm not going to use array. Instead, I will use only individual cells. Let me take parallel strings as 1 as well as series strings as 1. Hereafter, it will be called as PV array. Apply. And whatever the model I used, it's a user defined one, but you'll be having a lot of models are available with different power ratings. You can pick anyone according to your requirement. So what will be the input of hereafter? It is called as PV cell. The output of PV cell, it will always give you DC output, DC voltage. You can see there will be two inputs. One is irradiance and second one is temperature. The standard operating condition of PV cell is 1000 watt per meter square as irradiance and 25 degrees Celsius as a temperature. So this will be the standard operating conditions of solar photovoltaic cell. I'm going to use this as my input. It's a constant one. But in real time, if you want to use a variable input, you can use actually the solar PV insulation, solar insulation. Let me take a constant. This is 1000 because it's irradiance in watt per meter square. And I'm taking one more constant, let it be 25. This is temperature in degrees Celsius. So this irradiance is given as an input here. And temperature is given as input. Now I'm going to take a diode. I don't want the input. So this diode will act as a bypass diode. Suppose in olden days, if you are purchasing solar photovoltaic cells, you have to purchase bypass diode also. This will safeguard the PV cells from reverse connection. Okay, but nowadays all the manufacturers manufacturing the solar photovoltaic cells with inbuilt diode. But while simulating, you must add this bypass diode. It's mandatory. So that should be connected to the output side. It's a bypass diode. Similarly, I'm going to take 2 more cells. The same irradiance is given as an input to all the cells. Similarly, same temperature is given as input. Yes. So now I'm having 3 PV cells. I'm going to connect all the PV cells in series. So how to connect it in series? The negative of first cell will be connected with the positive of second cell. Similarly, negative of second cell will be connected with the positive of first cell. Therefore, this is called as string. If the number of cells are connected in series, it is called as strings. If the number of cells are connected in parallel, it is called as module. The combination of string and module is called as array. Okay. The same way, I'm going to take 3 strings. Right. Now again, I'm going to connect all 3 strings in parallel way. So each and every string, I'm going to add one more diode. So how to connect it in parallel? We know that the positive of all strings are tapped in a single line and the negative of all strings are tapped in a single line, then that is called as parallel connection. So now it is all the positives are tapped in a single line. Similarly, I'm going to tap all the negatives. So now we'll be having one whole positive and negative here. So this structure is nothing but it's a PV array. Okay. So hereafter you can connect if you want to measure the voltage across the PV module and if you want to measure the current through the PV module, you can measure it. Let me take a voltage measurement. So we know that always we connect the voltage measurement in parallel. This will give you voltage. Suppose if we want to measure the current, we need some more additional component because we have to connect it in a closed loop. So for that, I'm taking a component called controlled voltage source. Controlled voltage source. So for this controlled voltage source, I'm going to give some input called a ramp. So I'm considering the irradiation of sun is increasing from minimum to maximum. That's why I'm using the ramp signal. Let me take the slope of ramp is 10. Just apply. Okay. Now let me take a current measurement. The positive of sensor is connected here, and the negative of sensor is connected with the positive of control voltage source, and the negative you can ground it. You can connect it here. So the output, this will give you current signal. 10 amps. Suppose if you want to study the characteristic curve, you can take XY graph, don't take scope. Okay, so scope will always give you output with respect to simulation time. X-axis will be always time. But if you want to change the x-axis, you have to go for XY graph. So in this XY graph, I'm going to consider my x-axis is voltage and y-axis is current. Okay. Similarly, if you want to find out power, then take a product. So it's a DC voltage. So simply you can multiply this voltage as well as current will give you power. And take one more XY graph. In x-axis I want voltage, and y-axis it will be power. Right. So now the PV model is developed. It's done. Now if you want to simulate it, actually we have to change the model settings, then only it will works fine. Okay, just go to modeling, go to model settings, just go to solver details, change the relative tolerance as 1 to the power minus 10, otherwise it will throw you some error. Okay, iteration error. At the same time, change the solver method from automatic to, let it be, it's a trapezoidal method. Just click OK. Now the system is ready, model is ready for simulation. I'm just changing the simulation time. At least I want 50 seconds. Run the system. Yeah. Actually, we need a power guide. Without power guide, it won't work. Just keep it somewhere and make it as a continuous. No need to change. It's executed. So if you see the first graph, actually it is a voltage with respect to current. Actually it's building the graph. Yeah, I'm just going to format. There you can change the axis. I don't want up to 525. I want only up to, it will be 110, 120, 105 or 110. So you can see this. In x-axis we'll be having a voltage and y-axis will be having a current. This is the voltage versus current characteristic curve. Actually, here I'm starting with 0. Right. X. Okay. So this is the voltage with respect to current characteristic curve. You can see that initially, actually, during this portion, you'll be getting the voltage will be constant. Actually, sorry, the current is constant. You can see this. So that's why solar photovoltaic cell is also called as constant current source. It will also act as constant voltage source also. See, if you look at this, during this region, the current is constant. Okay, therefore you can use this solar photovoltaic cell as constant current source. But at the same time, if you look at this, actually, if you take this portion, you can see it looks like the voltage is constant. During this portion, the same solar photovoltaic cell will act as a constant voltage source. So over the period of time, actually the current falls to 0 value. Okay, if you want to see the voltage with respect to power graph, take this one. Yeah, similarly I don't want auto scale. I'm changing this from 0 to maximum of 110. 110 is enough. You can see. So initially the power will be very low. Actually in x-axis will be having voltage, y-axis will be having a, actually it's a power actually that I have to mention it. Okay. You can see initially the voltage will be, the power will be very low. Over the period of time with respect to that insulation, okay, the power is keep on increasing from 0 value to maximum. This is the place where you are obtaining maximum power, MP. After that, power falls to 0. Why? Because current is approaching 0. Okay, this is the point where you are getting maximum power. Okay. Actually, I have to mention this line. Little bit, this is power. Power in watt. Now it will be visible. Yeah. To run it. This is for showing only X label and Y label. Okay. So now X label is Y voltage and Y label is power. So it is showing some warnings because I didn't terminate this M port. M port is nothing but it is a measurement port. If you want to measure the voltage across the PV cell or current through the PV cell, individual PV cell, you can use this M port. Otherwise, Just use terminate it. You can terminate. You can use terminate. Okay. Then it won't show any kind of warnings. See, now it is executed. It's not showing any warning. Okay. So I hope this video will greatly help you to understand how to develop the solar photovoltaic module with the help of Matlab. Thank you. Kindly subscribe the channel. If you have any queries, kindly drop a mail to this mail ID. Thank you.